Secret codes of the Soviets and modern Russians. 3 tall Russian structures that shocked the engineering world.
Hello, Constructive Minds followers. If you think crazy construction only happens in Dubai or New York, you need to reconsider. Today, we've traveled to the heart of bold Russian architecture.
Exactly. Russia has always been a symbol of grandeur, but in structural engineering, they don't just build big, they build bizarre. Structures that are not only tall, but have stood against the toughest climatic conditions and history itself. Especially in Moscow City, where towers like Federation and OKO are competing with incredibly strong concrete cores and complex damper systems. Just imagine pouring concrete at sub-zero temperatures at a height of 300 meters.
Or even the older masterpiece, the Ostankino Tower. Those pre-stressed cables and its shallow foundation were a technical defiance of all engineering textbooks back in the 60s. How did they rely solely on weight and pre-stressing for that immense height?
Here's the challenge. On our YouTube channel, we have compared the construction industry of many countries around the world, like the US, China, Spain, and Singapore. Which country do you think has the craziest buildings? After watching this video about Russia, your opinion will definitely change.
We are not just looking from the outside. As civil engineers, designers, and structural analysts, we are diving deep to reveal the secrets of wind and seismic loading, critical joints, and the geotechnical challenges of these superstructures. Are the devastating fires in these structures a weakness or a testament to their exceptional resilience? We will answer this question purely technically in this video.
Hello, I'm Eleanor, meaning shining light. And together with my friend Theodore, we're going to take a look at Russia and analyze how Russian engineers, using secret codes, manipulated the laws of physics to construct 3 of the world's most bizarre structures.
We are Constructive Minds on YouTube. This is the place where a team of engineering and architecture specialists gather to uncover the secrets behind the world's urban masterpieces. If you love bizarre structures, engineering analysis, and bold architecture, then subscribe to the channel right now and hit the bell so you don't miss any exciting episodes.
Welcome to this explainer, where we're looking at 3 incredible structures that don't just shape Moscow's skyline, they really push the limits of what we think is possible in engineering. You know, in a place like Russia, with its massive scale and just epic history, that ambition gets physically built into its cities. We're going to see how that very background produced some engineering marvels that really made the world sit up and take notice. So today, we're going to break down the engineering secrets behind 2 modern titans of glass and steel, and 1 legendary concrete pioneer from the Soviet era. And by doing that, we'll see what their designs tell us about 2 totally different eras of ingenuity. All right, first up, let's talk about the symbols of a new globalized Russia. These are skyscrapers born from huge amounts of money, built with the absolute latest materials, and a world's worth of engineering knowledge. So right in the heart of Moscow's new business district, you've got these 2 giants standing side by side. They were built around the same time, they're nearly the same height, and they actually share a core structural philosophy. But as we're about to see, they solve the same problem, staying upright, in slightly different, really fascinating ways. The basic principle that holds both of these towers up is actually pretty simple, but incredibly powerful. Just picture this indestructible spine made of reinforced concrete running right up the middle of the building. This massive core does almost all the heavy lifting, fighting against gravity and, of course, the wind. And the Federation Tower? Well, it's a perfect example of what you might call a brute force engineering philosophy. To get that incredible height and stability, it just relies on sheer mass. We're talking over 600,000 cubic meters of high-strength concrete. That amount of material is it's unbelievable. But, you know, mass by itself isn't enough to stop a 374-meter-tall building from swaying like crazy in the Moscow wind. To really stiffen that huge structure, the designers used a really clever structural trick. And this shows it perfectly. They installed these gigantic steel arms called outrigger trusses that literally connect that central concrete spine to the outer columns of the building's skeleton. This basically locks the whole structure together, forcing it to act as one single, incredibly rigid unit against the wind. It's brilliant. Okay, now let's hop over to its neighbor, the OKO Tower. This one was designed by the world-famous firm SOM, and it relies less on pure brute force and more on a high-tech solution for a smoother, more comfortable ride for everyone inside. So here's the key difference. Instead of just fighting the wind, the OKO Tower kind of absorbs its energy. It uses these things called viscous dampers, and you can just think of them as giant, super sophisticated shock absorbers hidden inside the building. So when the tower starts to sway, these dampers turn that movement into a tiny bit of heat, which effectively calms the vibrations right down. But decades before these glass giants ever touched the skyline, Soviet engineers built something even taller. And they did it using a completely different philosophy, one that was almost impossibly clever and really born out of necessity. And this brings us to the Ostankino Tower, a true masterpiece of engineering ingenuity. Seriously, forget everything you think you know about skyscrapers needing deep foundations. The challenge here was to build one of the tallest structures in the world on what's basically just a concrete slab sitting right on the ground.
Yep, you are seeing that number right. 3.5 meters. While modern skyscrapers need these deep piles drilled way down into the earth, Ostankino just sits there. It relies on its own immense weight spread out over a wide base to keep from tipping over. It is an absolutely audacious, almost crazy idea.
So how on earth does it work? How does a thin concrete needle over half a kilometer tall take the force of powerful winds without just snapping in half? Well, the key, the absolute critical point, is its revolutionary stability system, dreamed up by its brilliant designer, Nikolai Nikitin. The secret is a technique called pre-stressing. See, concrete is incredibly strong when you squeeze it. That's called compression. But it's actually really weak when you try to pull it apart. Pre-stressing solves this problem by permanently squeezing the concrete so it can never be pulled into that weak state of tension. And this shows the method perfectly. Inside the tower's hollow shaft, you've got 150 high-strength steel cables stretched to an incredible tension, kind of like giant guitar strings. They are constantly pulling down, squeezing the entire concrete structure together. The analogy is perfect. It's like wrapping a really tight rubber band around a handful of pencils. They become one strong, solid column that simply can't be pulled apart by the wind. Okay, so let's put these three engineering marvels side by side. Because when you compare these totally different ways of building, a really fascinating story about the evolution of engineering starts to emerge. I mean, this comparison really lays it all out. You've got two completely different paths to reaching for the sky. The modern towers, they represent this globalized approach, using massive investment and the best technology money can buy. We're talking ultra-high-strength concrete, outriggers, dampers. Ostankino, on the other hand, is just this monument to clever, self-reliant ingenuity. It achieved its goal with pretty standard materials and one single game-changing idea. So what this all really shows is how each of these projects pushed Russian engineering to the next level. Ostankino proved the power of a single revolutionary concept. Then, decades later, the Federation and OKO towers showed a total mastery of the world's most advanced construction methods, bringing Russia right into the global high-rise community. And this leaves us with a final thought, a really interesting question. As we keep building higher and higher, what kind of thinking is going to define the landmarks of tomorrow? Is it going to be the brute force of immense resources and advanced materials, or will necessity once again spark the kind of brilliant, game-changing idea that gave us the Ostankino Tower?
Truly, the engineering masterpieces of Russia were beyond what many of us imagined. Theodore, what captivated you the most?
Without a doubt, Nikitin's audacity in designing the Ostankino Tower's foundation. The fact that he was able to stabilize a 540-meter structure with just a shallow annular raft is an engineering miracle even by today's standards. It proves that in engineering, there are always smarter and more elegant solutions than massive ones.
That's right. And on the other hand, the Federation and OKO towers demonstrate Russia's high capacity to integrate cutting-edge global technologies like ultra-high-strength concrete and viscous damper systems with their own climatic challenges. This engineering combination has set a new standard for tall buildings in cold regions.
So let's circle back to the main challenge. In this video, we have demonstrated with solid technical reasons how Russian engineers have pushed the boundaries of physics. Now, do you still think the craziest buildings in the world are in Singapore or China? If your opinion has changed, be sure to let us know in the comments and share your thoughts with the rest of the world.
This content was produced by the Constructive Minds YouTube channel. If you are interested in deep and engaging videos about construction and structures, subscribe to our channel. Hit the bell icon so you don't miss the next video, and if this video was useful to you, share it with your engineer, architect, or construction-loving friends.
Until the next video, goodbye.